Hello, AP Statistics. We have arrived at Unit 6, and yes, it is also Chapter 6, so that's why I've named the notes this way. So we are looking at Unit 6. We are in the middle of our information, so we are almost done. It's so exciting. Okay, so I know that many of you will find it ironic that I'm teaching you something called normal, since I am not, but that's cool. You know, if we were all normal, it would be boring. All right, so if you will look at the notes I've got here, these are just your notes filled in, okay? So all of the blue wording, that's all the stuff you should have gotten from your PowerPoint, okay? And then all the red stuff, that's extra, right? I know, you're welcome. All right, so let's talk about what a normal curve is. That's what this video is for. It is to illustrate to you what the normal curve is, the definition. So the first thing we need to talk about and understand for the normal curve is the fact that it is a density curve. So we've got lots of density curves, but we are going to hone in and just talk about the fact that the normal curve is a density curve for now. All right, so what makes it a density curve? Well, if you'll notice here, I'm not going to read this to you, but there are several things that need to be true, and I'm going to illustrate this to you. Since it always has to be on or above the horizontal axis, what that means is if I've got an axis here, then my curve is going to just sit on the top of it, just like that. And then the area underneath it consists of a total of 1. Why, Miss Griggs? Well, I'm getting to that. Hold on. And then, of course, it just describes an overall pattern of the distribution. You don't really have any perfectly beautiful curves in real life because real data is not perfect and beautiful. So the reason the area underneath the curve adds up to 1 is because it's all of the possibilities or all of the probabilities of all of the outcomes. And remember what we learned in probability already is that all my possible probabilities add up to, you guessed it, 1. So yes, we are still dealing with probability. I know everyone's excited. You're welcome. All right, so that is why we have the area under the curve equaling 1, because all of the possible probabilities live under the curve. All right, so when we talk about a density curve, what kind of data are we talking about? Well, keep in mind that we are just dealing with a mathematical model here. It is just idealized, it's not perfect, and it's not an actual set of data. It's really important that you understand that. It's just modeling something for us. That's all it's doing. So keep in mind now, we're not talking about discrete data like we were in our last couple of units. Now we're talking about continuous data. So this curve now represents all of the possible values, not just the ones that are countable. So if we had some outcomes, let's say we had outcomes of 1, 2, 3, 4, and 5, okay, and those were all of our possible outcomes. Well, that would work great for discrete data, but now we're not only going to be concerned with 1, 2, 3, 4, 5, but all of the decimals that fit in between 1 and 2, 1.001, 1.01, 1.5, 1.7, you know, there are tons of them. So now we're dealing with continuous data. All of the numbers are on the table for us. All right, so when we're talking about the normal curve, we need to discuss the center, the mean, and the median, and how they relate to one another. So when we think back to what the median is, if you'll recall from Unit 1, we talked about illustrating this using a box plot. All right, and remember we talked about the fact that the median is your 50th percentile right here. That means half of my data is on this side and half of my data is on this side. Well, the beauty of the normal curve is that it is symmetric, so the mean and median are going to be the same. And if you'll recall, when we first started talking about mean and median, if your distribution is skewed left, that means your mean is going to be lower than your median. If your distribution is skewed right, then your mean is going to be higher than the median. It gets pulled in the direction of the skew. So for our situation here, we're dealing with symmetrical distribution, and we'll get more into the details of that in a minute. So your mean and median are going to be the same. The letter that we let represent the population mean is the Greek letter mu. And no, it doesn't look that pretty when I draw it. It looks more like this, okay? So just get used to that. So that is what we call that. It's mu, okay? And it is the point right in the middle that kind of balances. Like if we were going to balance the curve on a point, that would be its balance. And then, of course, we need to always discuss our standard deviation. I'm going to use the Greek letter, which is a lowercase sigma, to represent that. We've already seen these symbols. This shouldn't be new to you. So keep in mind that your standard deviation controls your spread or your variability about the mean. So it tells us how the whole collection of data varies from or away from the mean. So that is same thing it's always meant. Okay, so our normal curve, if I could speak, our normal curve is a specific kind of density curve. So what makes it a normal curve as opposed to something else? Well, there are some specific properties that make a density curve a normal curve. And they are as follows. We must have symmetry. That means that when I look at a curve, this right here would represent the mean or median. And that means that 50% of my data lives here and 50% lives here. So it is perfectly symmetric. It is single peaked. In other words, it doesn't do this. Okay, notice one single peak right here. It is bell-shaped, obviously. You've heard of the bell curve, probably. And of course, it describes a normal distribution. So when we talk about the normal distribution, this is pretty much what you should have in your mind's eye. All right, so on your normal curve, your standard deviation can be roughly located by eye as the curvature changes, but I'm not going to make you do that, okay? We're just going to, we are just going to eyeball it, but I'm going to show you how to do that when we get into more specifics. Okay, the other thing we need to always remember about our normal curve, since it is a density curve, that means the area underneath it, always 1. I cannot emphasize this enough. Please remember this. The area underneath the normal curve is always 1. When, Miss Griggs? Always. That's, yeah, for real. Okay, so how do we write the notation for a normal distribution? Well, remember, we've already talked about binomial and geometric distributions. And remember what we used for binomial? We used a big B, and then the mean and standard deviation in the parentheses. We do the exact same thing for the normal curve. It's just now we use a big N because we're dealing with the normal curve. So when we define the parameters of a normal curve, we start with the mean, and then we talk about the standard deviation. So in other words, if I have a distribution with a mean of 500 and a standard deviation of 100, and I know it's a normal distribution, I am going to write that just like that, in 500, 100. So that is just your basic intro to what is a normal curve, what does it look like, etc., etc. In the next video, I will get into more specifics, and we will have great fun from here. You're welcome.